All right, let's look at our sample test for sections 13.1 to 13.5. So for number 1, we want to find the first 4 terms of the sequence given by a sub n is equal to 5 plus 1/4 to the n. So for the first term, we're going to put 1 in the place of n. So same thing here, we're going to put 1 in the place of n. And so that would be 1/4 to the 1, or 1/4, so just 5 and 1/4. All right, then for our second term, we're going to put 2 in the place of n. So 2 in the place of n would give us 1/4 squared, which is 1/16, so 5 and 1/16. And then when we plug in 3 for n, plug in 3 for n, 1/4 cubed is 1/64, so 5 and 1/64. And then plug in 4 for n, plug in 4 for n, 1/4 to the 4th is 1/256, so 5 and 1/256. Now, another way that we could do that is we could put our 5 plus 1/4 to the n in y equals. Now, we have previously set our calculator in sequence mode, so we hit our mode button and just switched it from function to sequence. And then we went to y equals and we put in our equation 5 plus 1/4 to the n. And then we could go to our table and you can see those values right here. So that's another way that we could do that if we wanted to. All right, then for number 2, we have a recursive sequence. So number 2 says a sub 1 is equal to 9. And they want us to, again, find the first 4 terms of the sequence. So there's the first one. So I want to find a sub 2. I'm going to put 2 in for n, put 2 in for n, put 2 in for n. So if I put 2 in for n, that's going to give me 2 minus 1 is a sub 1. And then 2 in for n would be plus 2. So it would just be a sub 1 plus 2. So they had to tell me what a sub 1 was, otherwise I wouldn't know this value. So they told me a sub 1 is equal to 9. So let's replace a sub 1 with 9, and we'll have 9 plus 2 is 11. All right, then we want to find the third term, a sub 3. So let's put 3 in for n, 3 in for n, 3 in for n. So if I do that, 3 minus 1 is 2. That's going to be a sub 2 plus 3. So a sub 2 just a second ago was 11, right? So that's going to be 11 plus 3, or 14. All right, then a sub 4, I'm going to put 4 in for n, put 4 in for n, and put 4 in for n. So 4 minus 1 is 3. That gives me a sub 3 plus 4. A sub 3 just a second ago was 14, so 14 plus 4 would give me 18. So the first 4 terms in my sequence would be 9, 11, 14, and 18. All right, then for number 3, they asked us to evaluate some factorials. Now, if you try and put this in your calculator, it's going to give you an error message. It's going to say error overflow. Your calculator can't compute this, but you can. So 102 factorial literally means 102 times 101 times 100 times 99 times 98 times 97, 96, 95, 94, right? And then 98 factorial is 98, 97, 96, 95, 94. So these 98 and on down, 98 factorials, drop each other out. And that leaves us with 102 times 101 times 100 times 99. And so we can multiply those to come up with our answer. All right, then for number 4, they gave us 0 factorial. 0 factorial is just 1, and if you happen to forget that, you can get that from your calculator. And I also wanted to remind you of how we get factorials on our calculator. So 2 different ways to do that. You can hit your math button in the first column, and when you do, this menu will pop up, and you can arrow over to probability and then go down to number 4. That's one way to get your factorial. So you would put the number in first, and then go to math, over to probability, down to number 4. Another way that you can do that is if you have the new operating system, if you do alpha window, then this menu pops up, and so you can see your factorial there as well. So again, I would put in 0, and then I would do alpha window, and then I would choose number 9 to put my factorial on there. All right, then for number 5, we have a summation from 1 to 5 of 5k plus 3. So this is our lower limit of summation. We're going to start by plugging in 1, and then we're going to plug in 2, and then plug in 3, and then plug in 4, and plug in 5. And I stop when I get to 5 because this is my upper limit of summation. So I went through, and first I'm going to plug in 1, so 5 times 1 plus 3, then plug in 2, 5 times 2 plus 3, plug in 3, plug in 4, and plug in 5. Now, the sigma is what tells me to find the sum of those things. So that's why we put the plus signs in between. It's the sigma that tells us to do that. All right, so then we can just find each of those values and add those up. Now, you also can do summations on your calculator. So again, I'm going to go to the same place we did just a moment ago. I'm going to do alpha window, and number 2 there is my sigma. So if I choose number 2, it literally is going to put sigma notation on my calculator, and it gives me a little block down here to put any variable I want. I just hit my X button, and because I'm in sequence mode, it put an N. You could use any letter there that you want to, but whatever you use here, you have to use over here as well. So again, our lower limit of summation was 1, our upper limit of summation was 5, and then this is what we were evaluating, 5n plus 3, and so there's that same 90 that we got doing it by hand. All right, number 6 says, are the following arithmetic, geometric, or neither? And if it's arithmetic or geometric, find the formula for the nth term of the sequence, and then find the 10th term. All right, so let's start with this first one. The way that we know if it's arithmetic is if it has a constant difference. 11 minus 5 is 6. 17 minus 11 is 6. 23 minus 17 is 6. So you can see that constant difference of 6. So D is 6, and this is arithmetic. If that had not worked, if I had not had a constant difference, I would have checked for a constant ratio. All right, so since it's arithmetic, here is our arithmetic formula. And so we're going to put 6 in for D. And to find C, it's just going to be our first term minus our difference. So our first term right over here was 5, right? And again, our difference was 6. So we can say first term minus difference, that would be -1. So we'll put -1 right here for C. So there's our formula. A sub n is equal to 6n minus 1. That's the formula for the nth term. Then they ask us to find the 10th term. So let's put 10 in for n. Put 10 in for n, and we'll get 60 minus 1, which is 59. All right, look at the next one. So for the next one, if I say 4 minus 1, I get 3. If I say 9 minus 4, I get 5. So I do not have a constant difference. It is not arithmetic. So then I check to see if it's geometric by dividing. 4 divided by 1 is 4. 9 divided by 4 is not 4. So it does not have a constant ratio. So that is what a neither looks like. And in actuality, this is 1 squared, 2 squared, 3 squared, 4 squared. So if we had to write a formula for that, it would be squares. But notice they only asked me to write a formula if it was arithmetic or geometric. All right, look at number 8. For number 8, if I take the second term and subtract the first, -4 minus a -8 would give me -4 plus 8, so +4. And then if I did -2 minus a -4, that'd be -2 plus 4, so that'd be +2. So I am not getting a constant difference. So now I want to look for a constant ratio. So second term divided by first. So if I did -4 divided by -8, that gives me +1/2. -2 divided by -4 gives me +1/2. So I have a constant ratio of +1/2, and that means this is geometric. So here's my formula for the nth term of a geometric. A sub n is equal to a sub 1 times r to the n minus 1. So a sub 1, that's my first term, right? So if we go back, remember our first term was -8. So first term times our ratio, just a second ago, we got our ratio was 1/2, right? So ratio 1/2 to the n minus 1. Now, please remember, you cannot combine these. You can't say negative 8 times 1/2 is negative 4 to the n minus 1. It's only the 1/2 that's getting raised to the n minus 1. Okay, so that's my formula for the nth term. Now let's go find the 10th term. So we'll plug 10 in for n, plug 10 in for n, so 10 minus 1 would be 9. So we'll have negative 8 times 1/2 to the 9th, and 1/2 to the 9th is going to give us 1 over 512. And so negative 8 times that would be negative 8 over 512. And we could simplify that fraction to be negative 1 over 64, or you could give that as a decimal as well. All right, number 9, let's find the sum of the first 90 even numbers. So first off, I want to kind of envision what I'm talking about here. So first 90 even numbers. So, if we start counting by twos, 2, 4, 6, 8, 10, 12. So first off, I need to figure out, is this arithmetic or geometric? So 4 minus 2 is 2, 6 minus 4 is 2. So this is arithmetic, and I'm trying to find a sum, so we're going to use our Arithmetic Sum Formula. So this is our formula. And we're trying to find the sum of the first 90 terms, so let's put 90 in for n, put 90 in for n. Our first term was 2, but we do not know our last term. So we're going to need to come over here and figure out what our last term is. Now, if you want to use common sense to get that 180, you can, but we're also going to use our formula here. So I'm looking for the nth term of an arithmetic. So my formula for that is a sub n is equal to dn plus c. All right, we are looking for the 90th term, so n is 90. Our constant difference, if we say 4 minus 2 is 2, 6 minus 4 is 2, you can see that difference is 2. N is 90. And then C is going to be the first term minus the difference. So the first term was 2 and the difference was 2. So this will be 0. So our 90th term would be 180. So that's going to be a sub 90, or the last term in our sequence. All right, so 2 plus 180 is going to give us 182, and then 90 divided by 2 would be 45. So 45 times 182 is going to be 8,190. All right, then for number 10, we wanted to find the sum of the first 90 odd numbers. All right, so envision what that looks like. 1 plus 3 plus 5 plus 7 plus 9. All right, so again, I need to figure out, is this arithmetic or geometric? So 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2. This is arithmetic with a constant difference of 2. So let's use our arithmetic sum formula. So we're finding the sum of the first 90. So let's put 90 in for n, put 90 in for n. Our first term was 1. I do not know what the 90th term is. I got to find that. So I'm going to come over here and I'm going to find my 90th term. So put 90 in for n. We said our difference was 2. Put 90 in for n. And now I need to come find C. So C is the first term minus the difference. Our first term was 1 and our difference was 2. So 1 minus 2 is going to give us negative 1. So C is negative 1. So 2 times 90 would be 180, minus 1 would be 179. So that is my 90th term. That's the last number in the sequence that I'm finding the sum of. So a sub n, a sub 90, my last term is 179. So 179 plus 1 is 180 times 45 is going to give us 8,100. All right, then for number 11, we have the summation from 1 to infinity of 3 to the 1 minus k. And they said find the sixth partial sum. So the sixth partial sum means the sum of the first 6 terms. So basically we're finding from 1 to 6. All right. So we could go through and first plug in 1. So that would be my first term. Plug in 2. That'd be my second term. Plug in 3. That'd be my third term. And 4 and 5 and 6. And so you could just find what each of these values is and add them up. That'd be perfectly fine. But if they give me something like the 20th partial sum, I don't want to have to find all 20 of those and add those up. I definitely would want to use a formula then. All right. So I need to figure out, is this arithmetic or geometric? So when I plugged in 1, 1 minus 1 is 0. So 3 to the 0 is 1. If I plug in 2, 1 minus 2 is negative 1. So 3 to the negative 1 is 1/3. Plug in 3, 1 minus 3 is negative 2. So 3 to the negative 2 is 1/9. So 1/3 divided by 1 is 1/3. And 1/9 divided by 1/3 is 1/3. So my ratio is going to be 1/3, and this is geometric. So I'm going to go get my geometric sum formula. Now, this is finite because they only asked me to find the sum of the first 6 terms. So I'm going to use the finite geometric sum formula. Here it is right here. So if we're putting 6 in for n, our first term, remember, was 1 right here. So put 1 in for the first term. My ratio we established was 1/3, so 1/3 in for the ratio, 6 in for n, 1/3 in for the ratio. All right, and we can throw that into our calculator, and you can give it as a decimal or as a fraction. This would be good to give me the setup on your test because it's easy to put this in your calculator incorrectly, but if I can see you set it up correctly and, just put it in your calculator incorrectly, then I can just take a point off. All right, then number 12, that exact same formula, they ask us to find the sum to infinity, find the infinite sum if it exists. All right, how do we know if it exists? Well, the absolute value of the ratio has to be less than 1 or I cannot find the sum. So remember just a second ago, our ratio was 1/3. The absolute value of 1/3 is 1/3. That is less than 1. So yes, I can use my infinite geometric sum formula. So again, it's going to infinity, and I'm finding the geometric sum. So that would be a sub 1 over 1 minus r. That's my infinite geometric formula. A sub 1 was my first term. That was 1. And then 1 minus my ratio. Ratio again was 1/3. So that's going to be 1 divided by 2/3, which is the same thing as 1 times 3/2. And so we would get a sum of 3/2. All right, for 13, it asks us to find the sum of the series. And you'll notice that the dots go off to infinity here. And so we know that, again, this is an infinite sum. So let's see if it's arithmetic or geometric or what it might be. So if we do 10 divided by 5, that's 2. 20 divided by 10, that's 2. My ratio is 2. Now remember, the only way you can find an infinite geometric sum is if the absolute value of the ratio is less than 1. The absolute value of 2 is 2. 2 is not less than 1. So if the absolute value of the ratio is not less than 1, you cannot find the sum. And so you can just say no sum or diverges. All right, then for 14, it says 4 people want to ride a sled down a mountain. If only 2 of them are willing to ride in the front seat, how many ways can they be seated on the sled? Okay, so here are the 4 seats on the sled. So here's the front seat, and then the second seat, the third seat, and the fourth seat. I'm just drawing little blanks for myself. And so only 2 people are willing to ride in the front seat. So this first possibility with my fundamental counting principle, the first event can only be done in 2 different ways. There are only 2 different people that could sit in that seat. Okay, so somebody is sitting in the front seat now, and everybody was willing to ride in the second seat. The only restriction was the front seat. So there were 4 people. Somebody sat down in the first seat, so there are only 3 people left that could sit in the second seat. And then once they're seated, there's only 2 people left to sit in the next seat. And once they're seated, there's only 1 person left to sit in the last seat. So fundamental counting principle says if the first action can be done 2 ways, and the second one can be done 3 ways, and the third one 2 ways, and the fourth one 1 way, that I multiply those values. So 2 times 3 is 6, times 2 is 12, times 1 is 12. There are 12 different ways that they could be seated. All right, then 15, how many different license plates can be formed if there are to be 5 letters and 1 number? Okay, so I've got 5 letters followed by a number, and on my license plate you can have repeated letters. So we are going to say there are 26 different letters that could go in the first spot, and then 26 different for the second spot, 26 for the third, for the fourth, and for the fifth. All right, and then I'm going to multiply that by one number. Now there was no restriction on the number, so it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to multiply those values to come up with our total number of possibilities. All right, for 16, it says how many different 5-digit numbers can be found. All right, so I'm just going to go ahead and give myself 5 blanks here. 1, 2, 3, 4, 5. And it says first, how many can be found if the leading number can't be 0 and numbers can't repeat? Okay, so if the leading digit can't be 0, it can be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So there are 9 possibilities for that first number. Then it says that numbers can't repeat. So even though right here I can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there'd be 10 possibilities here. Whatever number I used right here cannot be used again. So even though I have all 10 numbers to choose from, I used one of them right here. I don't know what it is. I don't need to know what it is. I have 9 numbers left that could be used here. All right, now I've used 2 numbers, so now there's only 8 left that can be used here. And then there's only 7 left, and then there's only 6 left. So we can say 9 times 9 times 8 times 7 times 6. All right, then for number 17, it says, what if the number had to be even? So you can see it's a totally different question. How many different 5-digit numbers can be found if the number has to be even? So nothing, we don't have to worry about the leading 0 and not repeating. That was a different scenario. The only restriction on this 5-digit number is that it has to be even. So for the first digit, it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 possibilities there. There are 10 possibilities for the next one because I'm allowed to repeat. 10 possibilities, 10 possibilities. So in order for the number to be even, it has to end in 0, 2, 4, 6, or 8, right? So think about your even numbers, 10, 12, 14, 16, 18, 20, that kind of thing. So there would only be 5 possibilities for this last number. That will make it even. So we could say 10 times 10 times 10 times 10 times 5, and that would give us 50,000. All right, then for number 18 and 19, we want to evaluate permutations and combinations. All right, so first the permutation, our formula, this is our n value and this is our r value. So our formula is n factorial over n minus r factorial. So 8 factorial over 5 factorial. So 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 times 4 times 3 times 2 times 1 is 5 factorial. All right. So same thing here down in the bottom. 5 factorial would just be 5, 4, 3, 2, 1. So these will drop each other out and just leave us with 8 times 7 times 6, which is 336. Now, you also could do that on your calculator. So if you have one of the newer calculators, when you hit alpha window, this whole menu comes up and you have the NPR and the NCR down here. If you have an older calculator, it may not have those options. Okay, I'll show you another way to do that in just a second. But for this one, I'm going to choose number 7, NPR. And when I do, it just looks exactly like this on my screen. There's a block and then the letter P and then another block so that I can put my N in the first block and my R in the second block. So that's what we did. We put 8 in the first block and 3 in the second block, and there's that same 336 we got a second ago. All right. Another way that I could have done that is I can go to my first column, go to the math button, and then use the right arrow to go over to probability. And then you can see NPR and NCR right there as well. All right. So I would choose NPR. Now, depending on your calculator, it may put the little blocks on there, like we talked about this just a second ago. It may put the little block with the P in the little block, and you would fill those in. There are also some of the much older calculators that when you do that, it literally puts on your screen NPR. And it doesn't give you the option of putting the 8 where the N is or the 3 where the R is. In that case, you want to type your 8 first and then hit this button and then type your 3. And that's how you tell it to put the 8 in for N and the 3 in for R. All right, then look at the next one. The next one is 8C3. And so our formula for that is exactly the same, n factorial over n minus r factorial. It just has this one extra piece, r factorial. So we're going to have 8 factorial over 5 factorial like we did a second ago, but then we're going to multiply that by 3 factorial. All right, so you can see the same thing. We had 8, 7, 6, 5 factorial with the 5 factorials dropping out. The only difference is that 3 factorial, 3 times 2 times 1. All right, so 8 times 7 times 6 over 3 times 2 times 1 is going to give us 56. And again, we can do those combinations on our calculator as well. So the exact same way that we found NPR, whichever of these two works better for you, you would find NCR. And again, you can see we're just putting 8 in for N and 3 in for C and getting that same value. All right, so for number 20, it says, in how many ways can a class of 100 students elect a president, vice president, secretary, and treasurer? And then separately, as a separate question, how can they select a 4-member committee? Okay, so we need to think about, does order matter or not? Well, if we're picking different officers, then yes, it matters if you're first or fourth, because it's the difference between being the president or the treasurer. So order would matter. That would be a permutation. We have 100 people to choose from, and we're choosing 4. All right, so I worked it out by hand here. I also worked it out on the calculator down here. And remember that a permutation, you also can use the little blanks like we were using earlier. So 100 people could be the president, then there'd only be 99 left to choose from for the vice president, and then 98 for the secretary and 97 for the treasurer. And you can see that gives us the same answer. All right, if we're looking for how many ways a class of 100 students can elect a 4-member committee, it doesn't matter whether I get elected first or fourth. I'm still on the committee. So that would be a combination, 100 to choose from, choosing 4. And so you can see we worked it out by hand here, and we also put it in the calculator and got the same thing. All right, then for 21, how many ways can a baseball coach arrange his 9-member batting order if there are 18 people on the team? Okay, a couple ways that we could do that. There are 18 to choose from, and I'm choosing 9. And because it says in how many different ways can we arrange the batting order, having John bat first and Paul bat second is not the same thing as Paul batting first and John batting second. So the order matters. This is a permutation. So we could work it out with the formula. We could put it in our calculator, or you also, with a permutation, remember, can work it with the blanks. So I'm going to give myself 9 blanks for the batting order. There are 18 different players on the team that could bat first. And then after one of them bats first, there's only 17 left to bat second, 16 left to bat third, bat fourth, fifth, sixth, 7th, 8th, 9th. And so you can see that's going to give us the same answer as well. Now, if you put this in your calculator, it's going to give you your answer in scientific notation, because once the number gets too large or too small, it gives scientific notation. And this is your calculator's way of saying that. So it's saying 1.7643332256. E means times 10 to the 10th. So that would be this number times 10 to the 10th. So you can see if we took this decimal and we moved it 10 places, so right now it's right here, right? So move it 10 places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's that same number, okay? So on your test, don't write your answer in scientific notation. You should interpret what that is and give the actual value. All right, 22. How many ways can a student invite 25 out of 100 seniors to a graduation party? All right, doesn't matter if I get invited first or if I get invited 25th, I still get to go to the party. So that is a combination. 100 to choose from, choosing 25. Definitely throwing that one in my calculator, and here's what we get. So again, that's scientific notation for this number times 10 to the 23rd. So that would be like taking this decimal and moving it 23 places. All right, then for number 23, how many distinguishable ways can the word Pennsylvania be written? Okay, so basically we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters in Pennsylvania. So we have 12 to choose from, and we're choosing all 12 of them. So we said when that happens, that would be that number factorial. So we've got that number factorial right here in the top. The problem is when we have repetition, we would be counting the same things twice. And so we have to divide out that repetition. So for our formula for distinguishable permutations, we said it would be n factorial in the numerator. And then down here, it would be any repeated elements factorial. So because there were 1, 2, 3 n's, that's a repeated element. So I'm going to have 3 factorial. And there were 2 a's, one right there, one right there. So I'm going to have 2 factorial to get rid of that repetition. So we could work this one out by hand, as you see here, or we also could throw it into our calculator. We already saw earlier how to find our factorial button, so we could use that and get that same answer.